everyone, in this video we are going to see about the arithmetic operation instructions of 8085. In 8085 you can perform the arithmetic operation such as addition and subtraction. These two operations, arithmetic operations, you can perform in 8085, and you can't perform multiplication and division operations. These are all arithmetic operations. In logical operations, you can perform AND operation, OR operation, NOT operation, which is means complement, CMA, and XOR operation. Now we are going to see about this arithmetic operations. The first instruction is add instruction. This instruction is very simple, meaning you're going to add two numbers. We already know that one of the operand should be in accumulator and another operand in any of the registers. You have registers B register, C register. These are registers: B register, C register, D, E, B register, C register, D register, and E register. Now I am loading accumulator to 05. Then I can use any one of the registers. I am using D register and load 03. Now the instruction to add this two number is ADD D. By default, this instruction considers accumulator as one of the operand and the next operand in D register. You need not to mention that add A, D. There is no such instruction format in 8085 because all the arithmetic instruction, one of the operand is accumulator, so it is not necessary to mention the accumulator. You just give add and your register name, which register you are having. So this is the syntax: add register. Whatever register you want, you can mention. By this adding, your answer is stored to your accumulator. Accumulator plus your register content stored to your accumulator again. That means first, when I am giving A is equal to 5 and my register content is 03, now I am giving add register. Now my answer is in accumulator as 08. This is how it performs. If you get a carry in addition, at the end you get a carry, means in sign flag your carry bit is equal to 1. In this 5 plus 3 there is no carry, so your carry flag is 0. So whenever you are doing an addition operation, you should consider it generates a carry or not. It's very important. The second instruction in arithmetic operation is add with carry. That means ADC, add with carry, and you give any register name here. In this add with carry, in this instruction, it takes the carry flag into account. For example, by the previous process or any other process, your carry bit is set to 1. Now you're going to add 2 digits. You move the first value to accumulator as 05 and the second value in any register as 03. Now you perform ADC register, this instruction. Now your answer is 5 plus 3 plus 1. In this ADC, add with the carry, it also takes carry into the account. So 5 plus 3 is equal to 8 plus this carry is 1. So your output answer is 09 hexadecimal format. Now the carry flag is 0 because this addition operation not generate any carry bits. So your carry flag is 0. The same way, if your carry is 0 before your execution of ADC, you give A register as 0, 2 and your registers have a value of 0, 2. Now you performing ADC instruction. Now your output is 0, 4 and your carry is 0. Here 0, your carry is 0 plus this 2 plus this 2. So totally it is 4. This add with carry instruction is mostly used when you are performing an 16-bit addition operation by using 8085. In 8085 is an 8-bit microprocessor. It can handle only 8 bits at the same time. So you can easily perform 8-bit addition. But if you want to perform an 16-bit addition, you have to do two 8-bit additions. In that cases, this ADC instruction will be helpful. Now the third instruction is add immediate. So add immediate means immediate is an addressing mode. Here you can directly specify the value in the instruction. For example, if I want to add 03 plus 04. So first I have to load one of the value to accumulator 03. The next value you can directly specify in your instruction itself, comma value. So that means your instruction look like ADI add immediate with 04. When you execute this instruction, your accumulator is equal to accumulator plus 04. Now you specifying the value directly in the instruction, not through any register like before. In this before and all, in this add instruction you have to give another operand from any other registers like B register, C register, D register, E register, like that. In add immediate instruction, by instruction itself you can directly specify the value. The other operation is same, just you replacing this, mentioning the register replaced by your values indicated directly in your instruction. The next instruction is add immediate with carry. The same like your add with carry. So here what you are going to do is, first you have to load accumulator value is 03 and your immediate value ACI 04. This is your instruction you are giving. Here your accumulator value is 03 plus your immediate value 04 plus your carry flag. Your carry flag is 0 or 1. Based on before operation, the carry flag is set or not set. This is same as this ADC instruction, add with carry instruction. Here you replacing the mentioning of registers. You here mentioning your value directly in your instruction. This is immediate addressing mode. Now we see about DAD instruction. DAD instruction is nothing but it's a double addition. This instruction is used for 16-bit operation. This DAD operation will add two 16-bit register pairs. For example, I am giving DAD B. BC register pair is added with HL register pair. In your architecture, we can pair two registers, BC registers, you can pair as BC register pair, DE registers as DE register pair, another one is HL register pair. For example, if you are giving a syntax as DAD RX, RX means register pair is mentioned as RX. If I am mentioning DADD, that means DE register pair is added with HL register pair. The answer is stored in HL register pair. This is used for a 16-bit addition in a single instruction. Now we see about subtraction instruction. The subtraction instruction is same like your addition instruction. First instruction in your subtraction is SUB. Here also one of the operand is your accumulator. So subtraction with a register. For example, I am going to subtract 03 minus 05. Now first operand is stored in accumulator and second operand in any one of your register. That may be B register, C register, D register or E register is 05. Now you performing a subtraction operation, subtraction with any of the registers. Now your ALU performs accumulator minus the register which is you mentioned is equal to the answer is again stored in your accumulator. I am giving subtraction B. That means your accumulator minus your B register. This is a register. Okay. Answer is stored in your accumulator. Here you can ask a question that 03 minus 05 which results in a minus number. 03 minus 05 which gives minus 02. This 02 is your result. So your accumulator minus B register is equal to your accumulator. Now the accumulator is 03 minus 05 minus 02 is your answer. This 2 is in accumulator. This minus sign is stored in sign flag in your flag register, this bit. By checking the sign bit of your flag register, you can confirm the output is a negative value or not. If your output is in negative, can't take your answer in accumulator as it is. You have to do a 2's complement with your answer in accumulator to get the final result. I will explain it later. Here you can ask one more question, how the borrow is stored. Sometimes at the end of 8-bit operation you get some borrow bits. That borrow bits is stored in the carry flag, this carry flag. In addition, the carry flag stores the carry of your accumulator answer, ALU answer. In subtraction operation, the carry flag holds the borrow bit. The second instruction in subtraction is SBB. It is same as your ADC instruction, add with carry. Here it is subtraction with borrow. SBB register, your accumulator minus with your register content minus with your carry flag. That is, it holds the borrow equal to into your accumulator. For example, in your accumulator you are giving 08, in your register is 02 and there is some borrow 01. Now your answer is 05. This is subtraction with borrow. The next is immediate addressing mode, SUI, subtraction immediate. In this immediate addressing mode, instead of mentioning the registers, you mention your operand directly in your instruction. So SUI, your value. Now I have to perform a subtraction operation for 05 minus 02. In accumulator you have to load 05. Then in instruction SUI 02. You can mention your operand directly in your instruction. By executing this instruction, your ALU performs accumulator minus 02 is equal to your answer stored in accumulator. That means 05 minus 02. Now your accumulator, the value stored is 03. This is immediate addressing mode. Instead of mentioning any register, B register, C register or D register, you can directly give your values. The same way for borrow, that is SBI, subtract with borrow immediately. So the same SBI value. This is the syntax of this instruction. So here which considers your carry flag. in subtraction operation, your carry flag considered as borrow. 05 minus 02 minus your carry flag. This is subtraction immediately with borrow.